Hello, so today we are doing area of trapezium, area of kite, and area of rhombus. Okay, we're gonna start with area of trapezium first. So, what do we notice about this trapezium? Okay, the parallel sides are the top and the bottom. Okay, the top is 5, the bottom is 13. Okay, we're not going to use the formula in the textbook because I think it's confusing. You're just going to look at it and say there's 5 there, there's 13 there. So if the top is 5 and the bottom is 13, what's the average length across? So if I make the top big, if I take the two sides and then I tilt it so that they go straight, right? So instead of this, we have the two sides being straight. What would the length across be? So what we can do is we do 5 plus 13 and then divide it by 2, which will give us 9. Okay, so 5 plus 13 is 18. 18 divided by 2 is 9. That means on average, the length across is 9. Now, let's go back to area of rectangle. So if the length across is 9, the top is 5, the bottom is 13. So the length across on average is 9. Okay, so the length across is 9. The height is 6 meters. Okay, so if we know the length across is 9 and the height is 6, what can we do with those two numbers? Okay, we just do 9 times 6. Okay, so the 9 comes from here. The length across is 9. The height of the trapezium is 6. So 9 times 6 is 54. Okay, that's what area of trapezium is like. Now your teacher has to pause the video here for you to copy down the notes. Okay, so now we're moving on to area of rhombus and kite. Now, before we talk about the rhombus and the kite, I'm going to start with a rectangle. I am going to start with a rectangle. What's the area of this rectangle? How do you find the area of this rectangle? It's just x times y, because it's just the length times the width. Okay, so the area of the rectangle is just x times y. Now, what I'm going to do is I'm going to draw a line across the rectangle and a line down the middle of the rectangle, like this. Okay. Now, the next thing what you realize in this case is then we have 4 sections. So that's a rectangle there. There's a small rectangle. There's another rectangle there. There's a rectangle here. And there's another rectangle here. So there are 4 rectangles in this shape now. We're going to split all the 4 sides into 2 by drawing diagonals like this. Okay, so I'm going to connect this point to this point there. Similarly, I'm going to connect this to that. And then I'm going to connect this to that. And I'm going to connect this to that. Okay, so if you connect these 4 points, what you get is a kite. Now, what do you realize about this area here and this area here? Okay, they are the same area. They are the same area because all we did was we took a rectangle, this rectangle here, drawing the border of it. We took this rectangle here and we cut it in half. So this area is the same as that area. Okay, that also means that this area here is the same as this area here, which also means that this area here is the same as this area here. And lastly, this area here is the same as this area here. Okay, so what do you know about the area of the kite then? The area of the kite is just half the area of the rectangle, right? Because if this is the same as that, and this is the same as that, and this is the same as that, and this is the same as that, that means the kite is exactly half of the rectangle, which is how I get this formula, half xy, okay, or half the area of the rectangle. Now, important thing to note, x and y here doesn't refer to the sides of your kite. Okay, so it's not the side of the kite times the side of the kite. The x and y refers to the distance from one corner to the opposite corner. So the length from this corner to the opposite corner is x, and the length from this corner to the opposite corner there is y. Okay, the x and y doesn't refer to the sides of the kite. The x and y refers to the length across the kite. Okay, when it comes to rhombus, it's exactly the same. The example I gave here, that was 5 centimeters. That's 5. That's 5. That's 5. That's why it's a rhombus. Remember, a rhombus is just a square that you tilt to one side. Okay, so it's like a tilted square with 4 equal sides. Now, again, the x and y isn't 5. The x and y in this question refers to the length from this corner here, where my mouse is, to that corner there, times y, which is this corner here, to this corner here. It doesn't refer to the 5 centimeters. Okay, the teacher pause the notes now so they can write. Pause the video now so you can write your notes. And moving on. Now, we just mentioned that how to find the area of a rhombus. Okay, so the formula was half x, half times x times y. Again, I'm going to repeat, x and y is not 7. Okay, 7 is the side of the rhombus. That's not what we want. X and y refers to the length from one corner of the rhombus to the opposite corner of the rhombus. So from this corner to this corner, that's x, and x is 8 meters. From this corner to this corner is 6 meters, and that's y. So x is 6 and y is 8 meters. Okay, and again, do not forget the half. Rhombus and kite has a half in the formula. So the area of the rhombus in this case is just half times 6 times 8. Okay, 6 is the length across, 8 is the length across, you have it. So the area is half times 6 times 8. Okay, your teacher has to pause the video here so they can write the notes. Okay, moving on. Kite. Same idea again. What we are concerned about is the length across the kite from this corner to this corner, and the length from this corner to this corner. Okay, so we know that from top to bottom is 10 plus 4, which is 14. Right, 10, 4, 14. And across is 3 plus 3, which is 6. So the length across is 6, and the length from top to bottom is 14. Okay. The area is just half times 14 times 6, or half times 6 times 14. Doesn't matter which way you do it. 14 from top to bottom, and across is 6. Okay, so half times 14 times 6. Now in this case, because they give you the length of each section, you can also do the question the longer way. The longer way was to find the area of each triangle. Okay, so this triangle here, this area here, it's a 3 by 4 triangle. Okay, so it's a 3 by 4 triangle. Therefore, the area is half times 3 times 4. Okay, and then this triangle here, same thing again, half times 3 times 4. This triangle here, right, it's a 3 by 10 triangle. Sorry, it's a 3 meters by 10 meter triangle. So that means that the area of that triangle is half times 3 times 10. And then the last triangle is exactly the same, half times 3 times 10. That'll give you 6 plus 6 plus 15 plus 15, which is also 42. So this is the longer way of doing the question. You could have just done half times 14 times 6 instead of doing all this work, but they both give you the same answer. Okay, teacher, pause the notes now so you can write the notes down. You are to complete textbook exercise 505, page 167, question 1, and then move on to the next exercise. Exercise 506 on page 171, question 4. So you're doing one question of each exercise. So there's exercise 505 question 1, exercise 506 question 4. Okay, that's all there is for this lesson. I'll see you guys tomorrow, I think.